Hi, everybody. So today we're going to talk about how the molecules that we talked about last time, how they interact with each other. So all the atoms that you're made of, from the top of your head to the tip of your toes, are interacting with each other. That's what makes matter do stuff. And living matter, organisms, be doing all sorts of really cool stuff. And so atoms are interacting with other atoms all the time, and we call these chemical reactions. So if you just take a very simple chemical reaction, for example, you have here something called methane. That black ball right there represents the carbon, C, and you can just barely make it out in the back. There's 4 white atoms called hydrogen, and so that's C, 1C with 4 H's, right? Methane is what it's called. And if you take methane and you take oxygen, these are 2 oxygen atoms, O2, and we have 2 of them. If you take all those atoms and you rearrange them in all different kinds of cool ways, you can get a totally different arrangement of atoms. You can have the oxygens, take one of each of those oxygens and interact with 2 hydrogens each, and you get water. 1 oxygen and 2 hydrogens, you get water, and another water. And the carbon can interact with 2 oxygens and get carbon dioxide. So you have the same atoms you had here, methane, explosive gas, with oxygen, the stuff you breathe, rearrange all the atoms and you get the stuff you exhale, and water. Chemical reaction that's very explosive. It's a fire. And in fact, we burn methane because it releases so much energy. We do this reaction where we take methane and oxygen and combine it. It's add a spark. We have to put some energy in to make that happen. But then we can rearrange these atoms into simple carbon dioxide and water. And the energy has come out as heat. Simple chemical reaction. And we represent that with an arrow. We show all the atoms we started with on one side of the arrow and all the stuff we ended with on the other side of the arrow. And the arrow just represents time. That's a chemical reaction. Now, of course, we can use our molecular formulas to represent those atoms. So if you notice, we could start with methane, CH4, and 2 oxygen molecules, 2O2, and after time, and some energy and some other things that are necessary for this chemical reaction, you're going to get carbon dioxide and 2 molecules of water. Same exact atoms that we started with are there at the end. Nothing is made, no atoms come into being magically, none disappear magically. Whatever we started with, we ended with. The stuff we start with is on the left of the arrow. The stuff we end with is on the left of the arrow, the right of the arrow, and the arrow itself means time. Chemical reaction. Chemical reaction shows how atoms can be arranged to make new molecules. You can be combining them. You can be taking them apart. You can be taking one off and adding another, substituting one for another. And you can be switching atoms. There's all different ways that chemical reactions can happen, but they're the same atoms at the start, rearrange, new, same atoms in a new arrangement at the end. Chemical reaction. There's something called the law of conservation of mass, and that simply means all the atoms you put in at the beginning are still there at the end. They're just rearranged in different ways. So you're going to have, you're not going to have, over here, you're not going to have 2 carbon atoms on this side and only 1 here. Nothing disappears. You're not going to have 1 here and 2 carbon atoms over here. Nothing appears out of nowhere. So they're just going to be rearranged. So the stuff on the left, the stuff you start with, are called reactants. They're reacting with each other. These are the molecules that are going to be switching atoms back and forth between them. And the stuff on the right are the products, and the arrow represents time. Chemical reaction. It's all that those jumble of letters and numbers mean. The atoms you start with, rearranging, and the arrangements they're in at the end. So here's a really complicated looking chemical reaction. It's really not very complicated, but it looks kind of scary. You have a C6H12O6, that's sugar. And another C6H12O6, that's another sugar. They're called glucose, that particular kind. And if you hook them together, you're going to get a different kind of sugar. And you're going to get water. If you look, you've got 6 carbons and 6 carbons for a total of 12 carbons you started with, and you got 12 carbons to end with. You have 12 and 12, 24 hydrogens, but there's only 22 here. Oh, right, the other 2 hydrogens are there. So you started with 24 hydrogens, you end with 24 hydrogens. And you have 12 oxygens, 11 here and 1 over here, Absolutely. The atoms have simply rearranged. There's all the same atoms at the start and the beginning. This is really just what you put in the beaker. It rearranges. It's still all there at the end. Chemical reaction. Or in the beaker, what you put into the cell, it rearranges, and then you still have it in the cell at the end. And that's chemical reactions.